Hello there, and welcome back to the Science Sleepy Minds. Tonight the sky above you is dark, scattered with pinpricks of starlight, some red, some white, some faintly blue. They're all flickering stories from the past, billions of years old, each light wave a tiny postcard from somewhere far, far away. The Milky Way stretches above like a smeared paintbrush on velvet, and the air feels still, perfectly still. But here's the thing, space isn't. The entire universe is moving, stretching, shifting and changing under your very nose. You just can't feel it. But what is it you're looking at, really? You tilt your head back, try to take it all in. That canvas above you, does it go on forever? Or does it have an end? A cosmic wall, maybe. Something you could knock on, like a door. Maybe with a little brass handle and a do not disturb sign dangling from it. You probably won't survive long enough to find out. But let's think about it anyway. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. And hey, tell me where you're watching from, and what time it is where you are. I love seeing our little sleep-deprived global village in action. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're lying on your back, and the universe is staring at you. There's something deceptively innocent about the night sky. Maybe it's the twinkle, or the fact that we've gotten so used to seeing it that it no longer registers as completely absurd. You, a collection of molecules with weird dreams and unpaid parking tickets, are looking out at a 13.8 billion-year-old cosmic relic, and you don't even blink. Let's start small. You're on Earth. Roundish, rocky, spinning like a lazy fidget spinner around a yellowish star. That star is part of a galaxy, a spiral called the Milky Way, which contains at least 100 billion other stars, give or take a few billion, depending on who you ask or how much sleep they got. That galaxy is part of a larger structure, a group of galaxies, which is part of an even bigger structure called a supercluster. And then you zoom out again, and eventually you're left with what exactly? Just more stuff, forever? At some point your brain tries to tap out. You can almost feel the boundaries of your own imagination, like reaching the foggy edge of a dream you can't remember. That's where the good questions start. Is the universe infinite? And if so, can infinity have an edge? Let's be clear, this is not the kind of question that has a clean answer wrapped in a shiny NASA bow. It's the kind of question that makes astrophysicists sigh loudly into their coffee and wonder if they should have just gone into accounting. Here's a fun little reality check. Humans have never directly observed more than about 6.5 billion light years in any direction. That's not because our telescopes are bad, it's because light takes time to travel, and the universe has been expanding while that light was en route to us. So we're seeing the light from very ancient galaxies, but those galaxies are now way farther away than they were when the light began its journey. It's like someone mailed you a postcard from Paris in 1901, and by the time you got it, Paris had moved to Mars. The key term here is the observable universe, everything we can theoretically see. But beyond that, we don't know. Could be more universe, could be something else. Here's where history chimes in. The ancient Greeks, bless their philosophical little hearts, were already onto this problem. Anaximander, around 600 BCE, proposed that the Earth was floating in a vast, infinite expanse of something he called the apeiron, the boundless. But he didn't mean infinite the way we think of it now, more like uncontainable, undefined. It's the philosophical equivalent of shrugging with deep sincerity. Fast forward a couple thousand years, and Newton comes along. He imagined space as an infinite flat backdrop, a stage that extended forever, with no walls and no ceiling. Simple, logical, kind of boring. Then Einstein ruined it for everybody. His theory of general relativity told us that space isn't a passive stage. It's a stretchy, curvy, dynamic thing. It bends around mass and energy and it can expand. Suddenly, space wasn't infinite because it had to be. It could be finite and still have no edge. That's a twist. And yes, historians still argue whether Einstein fully grasped the philosophical horror of that implication. Let's back up. Imagine you're standing at the edge of a field. If the universe were truly infinite, then no matter how far you walk, you'd never reach the end. You'd just keep walking and walking and walking, and while your Fitbit might love that, your brain does not. Because an infinite universe raises some bizarre follow-up questions. For instance, if space is infinite, then it should contain an infinite number of stars, right? So why isn't the sky bright white, blinding with starlight from every direction? This is an old chestnut known as Olbers's paradox, and the answer lies partly in the fact that the universe had a beginning. There hasn't been infinite time for all that light to reach us yet. Plus, redshift, more on that in a later section, dims and stretches distant light into obscurity. Also, the universe is not infinitely old, which ruins a lot of infinity-based assumptions. Sorry, infinity. Then there's the possibility that the universe loops in on itself, like a 3D video game map where walking far enough in one direction drops you back where you started. In this case, the universe would be finite but unbounded, a closed shape with no edges, like the surface of a sphere but in more than 3 dimensions. Don't worry, you're not supposed to be able to picture that. If you can, you're probably dreaming already. This is where things get quirky. Some cosmological models suggest that if we had powerful enough telescopes and enough time, we might one day see our own galaxy from behind. Like the light would have looped all the way around the universe and come back. Creepy and oddly flattering. And yet, despite all this clever theorizing, we still don't know whether the universe is actually infinite. It might be, but it also might just be really, really big and shaped in a way that tricks us into thinking it's endless. Kind of like IKEA, but with fewer meatballs. Fringe theorists have even proposed that the universe could be sitting inside a higher dimensional space like a soap bubble floating in some vast cosmic bathtub. In that case, sure, maybe it does have an edge, but the edge isn't in our dimensions, and we couldn't reach it if we tried. And if that doesn't make you want to lie down and take a nap, I don't know what will. You're still lying under the stars, except now your brain is looping. Because here's the thing, that uneasy feeling you got when thinking about the edge of space, that's not new. You're not the first person to peer into the dark and wonder what lies just beyond. Thousands of years ago, long before telescopes and quantum fields, someone else, probably barefoot, probably annoyed with the cold, stared up at the night sky and had the thought, what if I just kept going? Like, really going? That brings us to one of humanity's favourite old fears, falling off the edge. The flat Earth idea wasn't just about geography, it was a cosmic comfort blanket. A world with an edge feels contained, predictable. You can build myths around that, put dragons there, or gods, or turtles. Of course, the ancient Greeks figured out the Earth was round centuries before the bear became standard knowledge again. Eratosthenes even measured Earth's circumference in 240 BCE using sticks, shadows, and a healthy dose of patience. But even then, the cosmos beyond Earth remained weirdly flat. You fast forward through history, Ptolemy, Copernicus, Galileo, and humans slowly upgrade from flat Earth maps to heliocentric models to elliptical orbits. The Earth may not have had an edge anymore, but the space? That was still up for grabs. And honestly, even now your brain hates edge-free environments. Evolution didn't prep us for thinking in unbounded geometries. You evolved to navigate forests and cliffs and rivers, not to imagine space stretching out forever without a single "caution, do not enter" sign in sight. So it makes sense you feel like you need to put a border on the universe. You want to know where it stops. You want a line you're not allowed to cross. Something that says, here's where reality ends and the weird stuff begins. But what if that instinct to imagine an edge isn't just misguided but completely inapplicable? Let's take a small leap from myth to science. Picture early sailors back in the age of maps that said, here be monsters. These were people whose entire worldview was based on the assumption that the ocean must end somewhere, that the world must have an edge. They imagined it like a giant tabletop surrounded by, what, a void? A waterfall into chaos? You picture a bearded sailor hurling a barrel over the rail, waiting to hear it scream as it plummets off the planetary ledge. But the barrel never screams, and you never fall off. The more you explore, the more you realize the world is round. You just keep going in circles, and the same may be true of the universe. If you're expecting a hard edge, a wall, a border, a place to stand and look into the nothing, you may be waiting forever. Space might not end, it might curve, it might loop. It might not be the kind of thing that can have an edge at all. Think about it. Does the surface of the Earth have an edge? No. You can walk forever, or at least until your knees give out, and you'll never find the end of Earth's surface. It's finite, sure, but you can keep going in one direction and eventually loop back to where you started. Now, imagine a 3-dimensional version of that, kind of cosmic hypersphere. You'd be floating through space going in a straight line, and after billions of light years, ta-da, you arrive back where you began. The tricky part? You wouldn't even notice, because in space, straight lines are only straight relative to the geometry they travel through. If the universe is curved just right, you might be travelling in a loop without realising it. And historians still argue whether Einstein actually anticipated that particular mind melt. He famously called his model of a closed, curved universe finite but unbounded, which sounds suspiciously like a riddle from a sleep-deprived math teacher. Finite but unbounded. It means there's only so much space, but no edge to bump into. No wall, no cliff, no awkwardly placed under-construction sign. And you start to wonder, how many of our biggest questions are poisoned by the way we're wired to think? How often do we mistake absence of answers for presence of edges? Because here's the thing, you're probably still picturing the universe like a big glowing snow globe. It has stars, galaxies, dark matter, and somewhere, a glass wall where the whole thing stops. Maybe you've even imagined a beyond the universe. A kind of void. A blank. A backstage area where God hides the ladders and spare parts. But according to modern cosmology, that's not how it works. There is no outside. Space isn't in anything. It's not like a planet floating in a box, it is the box. Let's slow that down. If the universe includes everything, then outside the universe is like saying north of the North Pole. It sounds meaningful, but it isn't. There's no direct section to go, no destination, just conceptual error. Of course, fringe theorists have tried to sneak past this with fun metaphors. One idea is that our universe is a brain, short for membrane, floating in a higher dimensional space, a kind of cosmic pancake in a multiverse griddle. And maybe, just maybe, this is another brain hovering nearby, and the gap between them is the outside. You can almost picture it, the edge of our universe brushing up against another, with gravitational whispers passing between them. Maybe that's what caused the Big Bang, a collision of brains. But those are just models, hypotheses. No one's built a telescope that sees through dimensional pancakes yet. Meanwhile, here on Earth, your best chance of understanding the edge of the universe might be letting go of the need for one. Not everything that feels true is true, and not every edge can be stood on. So you sit up slowly. The stars above you haven't moved, but something inside you has. The idea of an endless, edgeless cosmos isn't just unsettling, it's oddly calming. A kind of infinity that lets you drift forever without ever falling off. It's like being told the world is a maze with no walls. A dream you can't wake up from, but in the good way. And if you feel a little dizzy, well, you're in good company. Some of the brightest minds in history sat under the same stars and felt the same vertigo. You stay where you are, cross-legged now, still looking up. The sky hasn't changed, but your questions have. You're no longer just wondering if the universe has an edge. You're starting to ask what kind of shape could allow it to not have one. And yeah, this is where things go from weird to full-on what even is geometry territory. So let's do what all great thinkers do when they hit a brain wall. We go for a walk. You imagine yourself strolling across a featureless plain. No trees, no hills, just endless ground beneath your feet and a slightly judgmental breeze. You walk in a straight line, eyes locked ahead, and just keep going. If the universe were infinite, you'd never stop. But if it were finite and curved eventually, without ever turning, you'd end up back where you started. And that's the trick. When it comes to the universe's shape, it is not just about size, it's about curvature, how space bends or doesn't bend across vast distances. There are three broad possibilities cosmologists tend to argue over, like tired roommates fighting about thermostat settings. 1. Flat. In a flat universe, geometry works exactly the way you expect from high school. Parallel lines never meet, triangles add up to 180 degrees, and the cosmos stretches out forever like an unrolled yoga mat. Clean, comfortable, boring. 2. Closed. In a closed universe, space is curved inward, like the surface of a sphere. It's finite, but with no boundaries. Travel far enough in any direction, and you loop back to where you began, just like that imaginary walk you took earlier. Triangles here have angles that add up to more than 60 degrees, which is just the universe being sassy. 3. Open. Now this one's a little spicy. An open universe curves the other way, like a saddle. It's infinite, but in a stretch sort of way. Space keeps expanding forever, but it curves outward, and parallel lines slowly drift apart. Triangles have angles that add up to less than 180 degrees, which your geometry teacher would hate. So, which one are we living in? Well, according to the Planck satellite mission, which measured the cosmic microwave background, a fancy term for leftover Big Bang heat, our universe appears to be Really, really flat. Like absurdly flat. So flat that if it were curved at all, the curve would be too vast to measure within our observable universe. And yet, here it comes. Historians still argue whether those measurements can really confirm flatness, or if we're just ants mistaking the floor for the entire building. Here's the kicker. You can live inside a curved space and never know it. Just like you can walk around the Earth and feel like you're on flat land the whole time. If the curve is large enough, local observations won't pick it up. You would need to travel billions of light years before the geometry got weird enough to notice. That's why asking, what shape is the universe, is a little like asking, what's the shape of the ocean, when all you've ever seen is the shoreline. So let's push a little further into the realm of cosmic topology. Topology is the study of spatial properties that stay the same even when things are stretched or twisted. It asks questions like, if I warp this shape, do holes appear? Do loops close? Does the number of boundaries change? In other words, you're no longer just asking how the universe is curved, you're asking how it's connected. A common analogy here is the video game world. Imagine playing a game where when your character walks off the screen on the right, they instantly reappear on the left. That's a toroidal topology, like the surface of a donut but in a game. If the universe were like that, you could in theory see multiple copies of the same galaxy as light loops around and reaches us from different paths. Think cosmic déjà vu with more math. And yes, people have looked for signs of this. Researchers have searched for repeating patterns in the cosmic microwave background, like patches of light that mirror each other across the sky. So far, nothing conclusive, just a lot of noise, a few eyebrow raises, and several PhDs issued for valiant attempts. But what if, and stay with me here, the universe is shaped like something weirder? Like a Klein bottle, which has no inside or outside, or a three-torus, where every direction loops back on itself, or a dodecahedron, the 12-faced geometric gem that some researchers seriously proposed as the universe's true shape. Because why not? It's not like we've got blueprints. There's even a fringe theory that says the universe is a simulation, and the shape is just whatever the render engine allows. Like maybe space has edges, but they're just memory caps in someone else's cosmic graphics card. Which is the kind of thought that makes you sit down and seriously consider not finishing your taxes, and if your brain's starting to melt, you're doing it right. The important part is this. The shape of the universe determines whether an edge is possible. If the universe is closed, there's no edge. If it's open or flat but infinite, there's no edge within the space. And if it's finite but flat, well, then things get dicey. That last one's particularly tricky. A finite flat universe. Imagine a video game screen, but with wraparound edges. Finite in size, but no border you can ever reach. This would mean the universe isn't curved, but space still loops. You could eventually come back to your starting point, even though space itself feels endless. It's a bit like standing in a hall of mirrors where everything seems infinite, but it's really just clever repetition. And yes, this idea keeps cosmologists up at night. Or maybe it helps them sleep. Hard to say. So where does this leave you? Well, on a personal level, it means that your instinct to look for the edge might be as outdated as sailing west to find the end of the ocean. If the universe has a shape that curves, loops, or folds in on itself in just the right way, you'll never reach the edge, because there isn't one. Not because space goes on forever, but because forever folds, and you sit back again, eyes closed now, letting the thoughts settle. The stars are still above you, but now they feel different. Not lights on a ceiling, but windows in a dome you'll never finish mapping. And honestly, that might be enough for tonight. The ground is cool beneath you, the night air still. Somewhere off in the distance, a cricket starts up like a tiny broken violin, but you're too deep in space right now to care. You're floating, mentally anyway, far beyond Earth. Back in time, right to the moment when the whole conversation about edges, infinity and cosmic shapes got its first real kickstart. And that kickstart came from one of the weirdest, most dramatic moments in the universe's entire life story. We call it inflation, which sounds like a boring economic term or something to do with a bad pool float. But no, this was cosmic inflation, and it was wild. According to the current best model of the universe's origin, space didn't just expand, it exploded outward in a fraction of a second, faster than the speed of light. That's not hyperbole, that's not poetic language, that's actual physics. The universe doubled in size over and over again in the tiniest sliver of time, growing from smaller than an atom to something the size of a grapefruit, or maybe bigger. We're talking 10 to 36 seconds after the Big Bang. That's a decimal point followed by 35 zeros and a 1. A time span so short that even your last doomed attempt to microwave popcorn had more longevity. And here's the weird part. During that burst of inflation, space itself stretched. Not stuff in space, not light or matter. The fabric of space expanded, sammeled, like someone taking a bedsheet, grabbing two corners and yanking hard enough to flatten everything on it. Except, in more dimensions. This is where your question about edges starts to wobble again. Because if space expanded faster than light, then regions that were once close became cosmically distant in the blink of an eye, and those distances are still growing. Right now, whole galaxies are sliding away from us faster than light, not because they're speeding through space, but because space between us is expanding. Inflation made that possible, and it also broke everything. Before inflation, you might have had a small, tidy universe. Edges? Maybe. Boundaries? Possibly. But inflation cranked the size dial up to near infinite and smeared everything out. It's like baking bread with raisins in the dough. As the dough rises, the raisins, galaxies, get farther apart, not because they're moving, but because the dough of space is expanding. And if you make that loaf really big, the raisins near the crust might as well be in another universe. That's the thing about inflation. It doesn't just solve problems, it also introduces new ones. Like, why did it happen in the first place? What triggered it? Why did it stop? Historians still argue whether the inventor of inflation theory, Alan Guth, truly understood the philosophical earthquake he had started when he proposed it in 1980. His model fixed a few nagging physics issues, like why the universe looks the same in all directions, but it also opened the door to new weirdness, like infinite universes budding off from eternal inflation. We'll get to that delightful madness later. Here's what you need to know for now. Inflation smoothed out the early universe so completely that even if it had started with weird shapes or boundaries or edges, those features would have been stretched beyond detectability. Imagine drawing a tiny triangle on a balloon, then inflating it until the triangle is the size of a city. At some point, the triangle becomes so large and flat that you can't even tell it was ever curved. That's your universe. That's what inflation did. And that's why it's so hard to tell what the true shape of the universe is. Inflation wiped the blackboard clean. Still, some physicists think there may be traces left, little bruises on the cosmic microwave background. Tiny ripples that hint at what came before inflation. If those ripples ever match up in a weird way, they might even suggest a finite curved universe. Or something looped. But let's not get ahead of ourselves. We're still floating, remember? Letting the weirdness wash over us. Because now we get to another strange twist. The universe didn't just expand, it continues to expand. And not just expand, accelerate. Yeah, that's a later twist in the cosmic plot. We thought gravity would slow everything down eventually. But starting around 5 billion years ago, the universe started speeding up again, as if space itself had gotten a second wind. And what's driving that acceleration? Oh, just a mysterious force we call dark energy, which currently makes up about 70% of everything in existence. No big deal, you might think this has nothing to do with edges, but think again. If the universe keeps expanding faster and faster, then even if it has an edge, it's receding from us faster than light. We'll never reach it. We'll never even see it. Which raises the question, is an unreachable edge still an edge? Imagine living in a city surrounded by fog that thickens the farther you walk. You can try to get to the edge of town, but the fog always moves just out of reach. You can't see what's beyond. You're stuck inside your observable world and everything else remains unknowable. That's what inflation and later dark energy did to the cosmos. And that's why for all our data and telescopes and theories, we may never actually know whether the universe has an edge. It might not. But even if it does, it's behind a wall of expanding space we'll never break through. You might feel a bit cheated. You came looking for answers, and all you're getting is cosmic metaphors and bread analogies. But there's comfort here too. Inflation didn't just stretch the universe, it gave it structure. Without that rapid expansion, you wouldn't have galaxies or stars or you. The early chaos smoothed into patterns. The randomness formed order. So in a strange way, inflation made the universe both simpler and more confusing. It erased the trace of boundaries, but made everything more connected. It eliminated edges, maybe, and in doing so gave you this moment, lying in the dark, wrapped in the echo of a cosmic breath taken 13.8 billion years ago. And for now, that's enough. You drift, thought by thought, deeper into the cosmic dark. Space is big, fine, you've made peace with that. Maybe it's infinite, maybe it loops, maybe it's just really good at pretending it doesn't have an edge. But here's a new wrinkle. The universe isn't just sitting there stretching like taffy. It's moving, or rather everything in it is. Galaxies are rushing away from each other. Not casually, not like friends drifting apart after high school. No. They're fleeing, at speeds that make you clutch your seat and double-check the cosmic seatbelt. This all starts with a discovery that wasn't supposed to happen. Back in the 1920s, Edwin Hubble, the astronomer, not the telescope, though the telescope's kind of his legacy project, pointed a telescope at some fuzzy blobs in the sky and realised they weren't just distant stars, they were entire galaxies, huge islands of stars, far beyond our own Milky Way. And then he noticed something weird. The light from these galaxies was red-shifted, stretched out into longer, redder wavelengths, which, in physics speak, means those galaxies were moving away from us. And not just a few, all of them. This wasn't just Hubble having a bad telescope day, this was real. Galaxies in every direction were sprinting away like the universe had just told a very awkward joke and now everyone was leaving the room. The farther away a galaxy is, the faster it recedes. That's what we now call Hubble's law, a neat, horrifying little equation that says space is expanding and distant galaxies are riding that expansion like debris flung from an invisible explosion. Now let's be clear, these galaxies aren't moving through space and space itself is expanding. Think of a rubber sheet with dots drawn on it. Stretch the sheet and the dots move apart, not because they're crawling around, but because the sheet is growing. This makes the whole idea of motion in space a little absurd. In the large-scale universe, movement isn't always about going anywhere. Sometimes it's just about being carried along for the ride, like when your Uber driver takes a detour through the fifth dimension. And yes, some of these galaxies are receding from us faster than the speed of light. Which sounds illegal under Einstein's rules, but here's the loophole. Nothing in space is moving faster than light. It's space itself doing the stretching, and general relativity is totally cool with that. Physics, the original rulebook, is with fine print. Now here's where things get relevant to your sleepless, edge-obsessed mind. If the universe is expanding in all directions, then shouldn't it be expanding into something? You'd think so, right? But nope. This is one of those moments where your intuition slams face first into reality. There's no outside that space is growing into. Instead, everywhere in the universe is getting farther from everywhere else. It's not an explosion in space, it's an explosion of space. And you might remember from earlier the balloon analogy. Imagine dots on a balloon. As you inflate it, the dots get farther apart, but the surface of the balloon is a 2D space curving in a higher dimension. The expansion is happening on the surface, not away from it. There's no center on the balloon skin. Every point feels like the center of expansion. Now scale that up a dimension. Our universe could be like that balloon surface, except in 3 dimensions. Expanding, stretching, curving, but not into anything, just into more of itself. And this is where the edge conversation gets even slipperier. If the balloon has no edge, maybe the universe doesn't either. Maybe the fact that everything's moving away from you isn't a sign that you're special, it's a sign that every point in space is expanding from every other. And here's the freaky bit. If you were on a galaxy 10 billion light years away, it would look the same. Galaxies would be receding in every direction from that point too. From every galaxy's perspective, it's the still center of a cosmic explosion. That's not just poetic, it's actually true. So you ask, what about the edge? What happens when I travel far enough? Doesn't there have to be a wall or a cliff, or a sign that says you are now leaving the universe? Well, not if it's infinite, or if it's curved, or if inflation and expansion just keep pushing the edge out faster than you can ever chase it. Here's a sad, fun fact. Most of the universe is already beyond our reach. Light from many galaxies will never reach us, because they're receding faster than light, thanks to the accelerating expansion we talked about earlier. We will never see them, ever. Not even with future telescopes or fancier math, they are gone. Not exploded or erased, just permanently outside our observable patch of reality, like a show you missed the premiere of, and now it's been cancelled and pulled from streaming. So maybe the question isn't, does the universe have an edge? Maybe the better question is, how much of the universe are we permanently cut off from? And that answer is most of it, seriously. If the observable universe is about 93 billion light-years across, then the actual universe could be trillions of light-years wide, or infinite, or some strange looped structure that defies distance altogether. But our little cosmic island, our light bubble, is all we'll ever get to explore. Now, here's a weird historical callback for you. Galileo once got in trouble for saying Earth wasn't the centre of the universe. And now, centuries later, we realise that every point is the centre of its own universe. Thanks to expansion, you're not special, but you're also totally central. So, cosmic participation trophy? And yes, that leads to all kinds of fun philosophical spirals. If most of reality is forever unreachable, does it even matter? Are we the exception or the rule? Does it count as existing if we can never observe it? You can feel your thoughts stretching now too, like galaxies, getting farther apart and losing contact with each other. That's what space does. It stretches everything, even your understanding, and it turns the idea of an edge into something soft, blurred. Not a wall you can touch, but a limit that slips away every time you chase it. Like trying to catch a horizon on foot. You can run all day, and it'll still be right there, on the edge of what you can see, but never quite within reach. You're standing now, or rather imagining yourself standing, on the furthest edge of what we can observe, past the galaxies, past the scattered quasars and whispering remnants of long-dead stars, out where light is stretched to its absolute limit. And just beyond that line, like a painter who ran out of canvas, lies what? That's the edge that isn't there. See, the universe has this cheeky way of putting limits on things without actually drawing a line. It tells you can't go past this point, but not because there's a wall or a drop or a glowing sea onion that says, "End of universe, thank you for visiting." Instead, it says, beyond here, light hasn't reached you yet, and it probably never will. You don't hit an edge, you hit a horizon. Let's unpack that. The observable universe is everything from which light has had time to reach us since the Big Bang, about 13.8 billion years ago. But because the universe has been expanding the whole time, the actual radius of this observable sphere is about 46.5 billion light-years in every direction. That number is already ridiculous. But the real kicker? That's not the size of the universe. That's just the size of our slice of it, the part we can see. The rest? Well, it's there, probably, but we can't get to it. Not now, not ever. When people ask, if the universe is infinite, how can it have an edge? They're asking a question that breaks down the moment you realise we're trapped in this bubble of visibility there. And that bubble has a limit, not because the universe ends, but because light does. Or rather, light runs out of time to reach us. Imagine being in the middle of a vast foggy field. You can only see so far before the mist swallows everything. You might think that's the edge of the world, but it's not. It's just the limit of what light and time will allow. The edge of your experience, not the edge of existence. There's a word for this in cosmology, the cosmic event horizon. Unlike the event horizon of a black hole, which is scary and dramatic and tends to end poorly for anything that crosses it, this one is less bitey. It's more of a philosophical shrug. A horizon beyond which events can never influence you, no matter how long you wait, not even with infinite patience and a telescope the size of Jupiter. So you stand there at this imagined edge, squinting into the distance like a cosmic lifeguard. But instead of water, there's nothing. And instead of people yelling, "Help!" it's just space, refusing to answer your questions. Now let's get historical again, because humans have always had a complicated relationship with invisible boundaries. In the Middle Ages, scholars obsessed over firmaments, imagined spheres that surrounded Earth like layered glass domes. One for the moon, one for the sun, others for planets and stars. They were comforting, structured. You could point at them on a diagram. And eventually they were all wrong. Modern science replaced them with models that were bigger, faster, weirder, and lacking firm edges entirely. But here's the funny thing. Even now, with centuries of progress under our belt, we still kind of want a firmament, some final barrier, a cosmic fence line to lean against. It's uncomfortable to think the universe just goes on, or that it loops back, or that it doesn't even exist in a shape that allows outside to mean anything. And historians still argue whether the psychological need for an edge is what kept early cosmology stuck in Earth-centered models for so long. But back to you, standing at that fuzzy boundary where observation ends. Let's ask a dangerous question. What if you could go past it? Let's say you had infinite time, a perfect spaceship, and some deeply misguided courage. What would you find? Well, more universe. Probably. You wouldn't find a wall or a drop-off or a blinking cursor that says loading. You'd find galaxies, maybe different kinds, maybe familiar ones. Just more of them. Maybe ones that look weird and ancient because time plays tricks out here, but you would never know if they existed because no information from them can ever reach you. And that's the true edge, the epistemological one, the boundary between what can be known and what can't. It's not a physical thing, it's a light speed thing, a time thing, and if you're now squinting suspiciously at the sky like it's hiding secrets from you, good. It is. Because here's the sneaky part. Even though we can't see beyond the horizon, the math says the universe probably keeps going. Maybe forever, maybe in loops, maybe in ways that don't obey our intuition at all. And what's beyond that? Here's where the fringe theories come in, sliding onto the stage in their tinfoil hats. Some suggest that space could be finite in size but wrapped in such a way that you never reach an edge. A finite but edgeless cosmos, like the surface of a sphere but in 3 dimensions. Others throw down the wild card. Maybe space transitions into something else entirely. Another universe, a boundary where the laws of physics change. Or, in some extreme ideas, a false vacuum, a region of unstable space-time that could collapse and rewrite the universe at any moment. Fun bedtime thoughts. And of course, there's the eternal inflation idea, where our universe is just one bubble in an infinite froth of expanding realities, each with their own rules, constants, and galactic soap operas. In that case, there is an edge. But it's not the edge. It's just where our bubble ends. And you can't go there either. It's like being a fish in a pond, wondering if there are other ponds. You can theorize, you can dream, but you can't swim through the air to get there. Not with your current fins. So maybe this is the part where you stop asking about edges and start appreciating the boundary of perception, the beautiful, blurry frontier where knowledge dissolves into speculation, where physics turns poetic and science becomes just another way of dreaming. The edge isn't a place, it's a thing. And it's where you are right now, balanced between what we know and what we can never reach. 1 foot in reason, 1 foot in wonder. You stare out again into that infinite dark and it stares back. You're floating again, not just in space now, but in thought. At this point, you've already accepted that the universe might not have an edge the way you once imagined. But here's a deeper layer of weirdness. Even if the universe is finite, it still doesn't have to have an edge, because now we're in the domain of topology, the mathematical art of stretching, twisting, and rethinking space without tearing it. It's like geometry's more chaotic sibling, the one who dropped out of art school to invent 4-dimensional donuts. So let's get tactile. You're holding a sheet of paper, flat, boring textbook geometry. If you walk off one side, you fall. Obvious edge. But what if you glue the left and right edges together to make a cylinder? You could walk around in a circle, no edge in sight. Now glue the top and bottom edges of the cylinder together. Congratulations, you've just built a torus, or what we'd call a donut. And if your little 2D self lived on that surface, you could walk forever in any direction and never hit an edge. You'd loop and loop again. That's topology. And if it works for donuts, it might work for the entire universe. Of course, in our everyday lives, this feels bizarre. We're used to boundaries. Doors, fences, parking lines. The idea of an environment that's finite but edgeless, that's something you normally need drugs or a doctorate to comprehend. But this isn't just abstract math. This is cosmological thinking. Scientists used a topology to what if the universe isn't infinite? What if it's just cleverly folded? Enter the concept of compact topologies. Think of a space that loops back on itself in multiple dimensions. The simplest example is a 3 torus, basically a 3-dimensional version of our donut model. In this universe, if you flew your spaceship straight ahead long enough, you'd eventually return to your starting point. That's right. You could, hypothetically, see the back of your own spaceship, eventually, after billions of years, assuming you don't hit a star or get bored first. This looping universe wouldn't be infinite, but it would be unbounded, no edge, no wall, no curtain to peel back, just continuous space with clever connections. And this isn't just sci-fi daydreaming. Cosmologists have actually searched for evidence of such topologies in the cosmic microwave background, CMB, the afterglow of the Big Bang. If the universe loops, then light might have circled the cosmos and arrived from multiple directions, creating matching hotspots in different parts of the sky. It's like trying to find repeating wallpaper patterns in the oldest light we can observe. So far, no luck, but the math says it's possible. Now here's where things get even stranger. Topology doesn't require your universe to look like a donut. It could be shaped like a Klein bottle, a 4D object where inside and outside merge in confusing ways, or a projective space where travelling in one direction flips you upside down and brings you back backward. Hope you weren't prone to motion sickness. In some of these shapes, light itself could loop, creating ghost images of galaxies across the sky. You'd be seeing the same structure from different directions, arriving from different epochs in time. A galaxy you observe on your left might be the same one you saw on your right, just 2 billion years younger, or older. Or in a really bad mood. And yes, physicists have looked for these echoes too. It's called the matched circle test, searching the CMB for circular patterns that repeat. But again, no conclusive hits. Historians still argue whether the absence of evidence here disproves looping topologies, or if it just means our universe is too big for us to notice the loops. After all, if the size of the looped space is larger than our observable universe, then we'd never detect it. The topological tricks would be happening off stage beyond the horizon, like a magician performing behind the curtain just out of sight. So maybe we're in a looped universe. Or maybe we're not. But here's the mental twist. Topology shows us that edges aren't required for limits to exist. Just because you can't walk off the edge doesn't mean you're in an infinite world. You might be in a hall of mirrors, or a kaleidoscope, or a four-dimensional etch, a sketch built by a mathematically unhinged deity. And here's a fun fringe idea. What if you could recognize the repeating patterns? What if someone somewhere already did? Some speculative cosmologists have joked that we might have seen the same galaxy more than once, from different angles and epochs, and not even noticed. Our data might already include light that looped around the universe, bounced off space's weird topology, and came back wearing a fake mustache, which means you're not just staring at the universe, you might be staring at echoes of itself. Or, in a very cosmic twist, at yourself, from another direction, from another time. And suddenly the idea of edges seems incredibly basic, like a child's drawing compared to a recursive fractal. So let's go back to your earlier question. Can the universe be infinite and still have an edge? Well, what if it's finite and still doesn't need one? That's the power of topology. It takes your assumptions and folds them until they look like origami cranes made of cosmic rubber. No walls, no fences, just shapes we can barely picture, doing things we can barely model, and you, here, curled up under the stars, are part of all of it. A thought looped through space. A mind asking if the thing it's inside of might be secretly folding in on itself. The answer? Probably not, but possibly yes. And that's the best kind of answer science has ever had. You're lying still now, as if afraid to breathe too loudly, in case the universe hears you and folds itself into a more confusing shape out of spite. But you keep going, keep thinking, because there's something that still doesn't sit right. You've heard it before, probably in a science class, a documentary, or that one friend who treats every party like a TED Talk. The universe is expanding like a balloon. Galaxies are dots on its surface. The balloon gets bigger. The dots get farther apart. Simple, right? Except, not really. The balloon analogy is popular because it's easy to imagine. It helps you picture how space can expand without needing a center. But here's the thing, it also breaks down in really uncomfortable ways. Let's start with what the analogy gets right. When you draw dots on a balloon and inflate it, the surface expands and the dots move apart. Crucially, none of the dots are at the center of the expansion. They all recede from each other equally. That's exactly what galaxies do in real space. There's no cosmic capital city, no Big Bang bullseye. Expansion happens everywhere, and the balloon's surface is two-dimensional while the balloon exists in 3 dimensions. So if we're living in 3 spatial dimensions, maybe the universe is a surface of some 4-dimensional thing. Maybe, but here's where your brain starts getting itchy, because the balloon expands into something, namely air and the space around it. But our universe isn't expanding into a larger space, it's not inflating inside a hyperspace warehouse or stretching into a galactic Costco. It's expanding within itself. It creates more space as it goes. So already the analogy is off. Because when you ask what's outside the balloon, in that model, you get an answer. Air, room, stuff. But when you ask what's outside the universe, you get nothing. empty space, not darkness, literally nothing, no space, no time, no matter, no direction, not even the concept of outside. This is what breaks most human brains, including yours probably. Because every experience you've ever had involves things happening in space, moving through it, standing next to it, and throwing something across it. But now, you're being asked to imagine space itself, not inside anything. It's like trying to imagine a book that exists without a shelf, or a fish with no water, or an internet argument with no comment section. So what is space expanding into? The answer is again that it's not expanding into anything. The more space isn't being added from anywhere, it's just happening. Space is being created between things. The galaxies aren't flying away from each other because they're being thrown. They're drifting apart because the fabric between them is stretching. Let's go back to that balloon, but this time remove the air, remove the room, remove the three-dimensional world around it. You're left with just the 2D surface, and that's all there is. That's the universe. The expansion isn't into space, it is space. Still weird? Of course. And yet this is the accepted model in cosmology. Now here's another wrinkle. In this balloon analogy, the further apart two dots are, the faster they move away from each other as the balloon inflates. That part's accurate too, and we see it in real data. Galaxies billions of light years away are receding faster than closer ones. But again, there's no central point, no origin of the expansion. Because in real space, every observer sees themselves at the center of galaxies rushing away. That's not ego, it's physics. You could be anywhere in the universe and you'd see the same thing, galaxies drifting off in all directions. That's not just a feature of inflation. It's a core tenet of modern cosmology, called the cosmological principle. It states that the universe on large scales is homogeneous and isotropic, uniform in every direction, which is a fancy way of saying you're not special, but also no one else is either. Now let's dive into a bit of cosmic trickery. What does it even mean for space to expand? Is the ruler changing? Is the distance between atoms stretching? Not really. On small scales, solar systems, galaxies, even galaxy clusters, gravity holds things together. Space might be expanding, but these systems are bound tightly enough that they ignore the larger scale stretch. They are like raisins stuck in syrup while the dough rises. They wiggle a bit, but mostly stick together. So when we say space is expanding, we're talking about intergalactic space, the vast stretches of nothing between galactic superstructures. But again, this doesn't mean galaxies are flying through space like shrapnel. It means space itself is changing size, and the galaxies are just riding along. And here's a final balloon-related betrayal. The balloon has a center. Even if it's not on the surface, it still exists in something. Our universe, as far as we know, it has no center. Not in space, not in time. The Big Bang didn't happen at one point and explode outward, it happened everywhere all at once. Every bit of space was once packed into an unimaginably dense state, and then it all started expanding together. Which means asking where did the Big Bang happen is like asking where is the center of the surface of a balloon? It's a category error. Historians still argue whether this misinterpretation is the fault of early popular science metaphors, or if the Big Bang itself was just too weird a concept to ever have a clean analogy. Either way, it leaves you here, metaphorically balloonless, sitting with the realization that even our best attempts to understand the universe are models, not mirrors. They give you a taste, not a complete picture. And maybe that's the secret, not to obsess over what the universe is expanding into, but to understand that the expansion is something that changes the relationship between things, not their location in some larger box. No edges, no outside, no universal floorboards hiding cosmic termites, just a dynamic, ever-growing web of space-time stretching quietly in all directions. And here you are, somewhere in the middle of it all, not because you're special, but because everywhere is the middle. It's humbling and beautiful and a little unsettling, but also kind of perfect. You breathe out long and slow, as if trying to match the pace of the universe's expansion itself. The idea that space stretches without stretching into anything still lingers like static behind your eyes. But before you can get too comfortable, another beast slinks into your thoughts. A big one, looming and unsolvable. Infinity. Here's where your sleepy spiral starts to wobble into full-blown math-induced vertigo. Infinity isn't just really big, It's not a number you can write down, or a place you can eventually get to if you're very determined and have snacks. It's a concept, and one that behaves with a kind of smug disregard for common sense. You've heard the idea before. The universe might be infinite, but saying that is like saying the ocean might be water. True, but completely unhelpful without context. Let's go down the rabbit hole anyway. Start by picturing a hallway. A really long one. You walk down it for days, months, decades. No end in sight. Maybe that hallway is the universe. Just an endless corridor of stars, galaxies, and awkward metaphors. Now try this. Imagine the hallway is lined with hotel rooms. Infinite hotel rooms. Welcome to Hilbert's Hotel, the most cursed Airbnb you'll never escape. This was a thought experiment from mathematician David Hilbert, designed to show how weird infinity is. The premise is simple. A hotel with an infinite number of rooms, all occupied, every single one, no vacancies. Now suppose a new guest shows up. In a normal hotel you'd turn them away, but not Hilbert. Oh no, instead you ask everyone to move over one room. Guest in room 1 goes to room 2, room 2 to room 3, and so on, forever. That frees up room 1, and the new guest checks in. Magic? No, just math. You can do this forever. Even if infinitely many new guests show up, you can still reshuffle the rooms in clever ways and make space. It's absurd. And it's a perfect example of how infinity doesn't behave like normal quantities. It's not just more, it's a kind of mathematical wild animal that refuses to be fenced in. So when scientists say the universe might be infinite, they're brushing up against the edges of human comprehension. If space goes on forever, then everything you can imagine probably exists somewhere. An exact copy of you sitting under an alien sky, asking the same questions with the same thoughts, possibly also in pajamas. Another you, but with blue hair, or with 3 arms. Or who never stayed up pondering cosmology in the first place and just went to sleep like a responsible person. Some versions of eternal inflation even suggest that every possible arrangement of matter must exist somewhere in this endless volume of reality. A cosmic library of Babel, where all stories, true or false, are playing out right now in infinite combinations, and no, there's no way to check. The distance is too vast, the repetition too perfect. It's a fun thought, until it's not. Because infinity doesn't just mess with location, it messes with meaning. If everything that can exist does anything matter? If you're just one version of an infinite set, is free will real? Are you significant? Are your thoughts unique, or just statistical noise in the void? These are not sleepy questions. These are the kind that keep philosophers and physicists staring into microwaves long after the popcorn's gone. And yet, here's the twist. We don't actually know if the universe is infinite. It might just be really, really big. So big that the observable part is a microscopic sliver. Maybe it curves back on itself. Maybe it has repeating patterns. Maybe it's finite but non-trivial. A topology that loops so subtly that no amount of telescope will catch the twist. And historians still argue whether ancient mathematicians like Zeno and his paradoxes were intuitively grasping the horror show that infinity would become. Remember Zeno? The guy who said you can never reach your destination because you always have to go halfway first and then halfway again? That guy was onto something. He didn't have the math, but he had the discomfort nailed. So where does that leave you, floating again? In a universe that might go on forever in all directions, no edge, no loop, no boundary, just infinite space, infinite time, infinite possibilities. And yet, you're here, right here, listening, wondering, breathing. In a strange way that anchors you more than any edge ever could. Because if the universe is infinite, then there's infinite room for you to exist. And for you to not exist. And yet somehow this version of you is real right now. Maybe that makes your version special, maybe it doesn't. But it certainly makes it worth noticing. You look up again, same stars, same silence. But now the sky feels deeper, not just vast but unbounded. A horizon that refuses to arrive. There's comfort in that if you let it sink in. Because sometimes knowing you'll never reach the edge means you don't have to rush, you just keep going, step by step, and thought by thought, dream by dream, and maybe somewhere out there infinity smiles back. Your thoughts are stretched thin now, threaded across billions of light years, tangled up in infinities, topologies and balloon metaphors that just don't hold air anymore. And yet something tugs at the back of your mind. A quiet itch you haven't scratched yet, What about time? You've spent all this mental energy thinking about space, how it bends, loops, expands, or refuses to end. But space doesn't exist on its own. It's part of a pair. Time is always there, lurking behind every movement, every question, every breath. You can't talk about the shape of the universe without dragging time into the room too, like a second roommate who insists on sharing the lease. Time and space are inextricably linked, woven together into what Einstein called space-time. A four-dimensional fabric that can bend and stretch and twist depending on what's in it. But here's the kicker. You don't just exist in space-time, you're made of it. Every atom in your body is shaped by it. Your mass bends it. Your movement slides along it. And the way time flows for you, that depends entirely on your motion and gravity. So yeah, time isn't just a ticking clock, it's a dimension. And it's just as weird as space, maybe weirder. Let's go back, way back, to the early 20th century. Einstein's theory of general relativity rewrote our understanding of the cosmos. Space and time weren't separate things anymore. They were a unified continuum. And mass didn't just sit there. It bent this continuum, creating what we experience as gravity. You don't fall toward Earth because of some invisible pull. You fall because space-time is curved and you're following the straightest possible path through that curve, which, annoyingly, leads down. And clocks? They tick differently depending on how deep you are in a gravitational well. Spend a few years orbiting a black hole and you'll return home to find your friends have aged decades. Also, you'll probably need therapy. That's not sci-fi, that's been measured. Time dilation is real. GPS satellites account for it. Your phone would send you to the wrong coffee shop if it didn't. So if space can be curved and finite without having edges, could time be the same? You pause. That's not a rhetorical question. Could time be finite but edgeless? Could it loop? Could it fold? Could you, in some strange ultra-long loop of cosmic recurrence, be living a moment that's already happened an infinite number of times? Philosophers have called this the eternal return. The idea that in an infinite or cyclic universe, every configuration of matter and energy must eventually repeat. It's a beautiful and horrifying thought that the stars above you have shone in exactly this way before, that you've thought this exact thought, blinked this exact blink, in a reality loop that curls through time like a snake eating its own tail. There's even a theory for it, cyclic cosmology. Some scientists, like Roger Penrose, have proposed that the universe may go through endless cycles of expansion and contraction, big bangs followed by big crunches, then new bangs again. In this view, time has no beginning and no final edge, just rhythmic change, a breath in, a breath out, repeat. And if that sounds poetic, it's because the math behind it is still open to interpretation. Historians still argue whether ancient myths about cosmic cycles, like Hindu or Buddhist cosmologies, were intuitive echoes of this idea, or just metaphorical stories about change. Either way, the idea of looped time complicates your edge obsession even further. Because what is an edge in time? Is it the first moment, the Big Bang, or the last moment when the universe goes dark, cold, and stretched thin? Or are those just landmarks on a road that bends back on itself? Another possibility. Maybe time is infinite in one direction but not the other. Like a ray in geometry, it starts at the Big Bang and keeps going forever, inexorably, tirelessly. But even that's up for debate. Some theories suggest time might emerge from more fundamental things, that it's not an ingredient of the universe but a byproduct, like temperature arising from the movement of particles. In this view, time is relational. It's not out there waiting to be measured. It only exists because things happen. And if things ever stop happening, if the universe reaches a state of perfect equilibrium, then maybe time ends. Not with a bang, but with a sigh. There's also a fun fringe idea, and by fun I mean brain scrambling, that time might not be fundamental at all. Some quantum gravity models suggest that, at the smallest scales, time disappears entirely, that it's a useful illusion for humans stuck in 3 dimensions. Try telling that to your calendar. So now we're here, wondering not just whether space has an edge, but whether time does. And if it does that mean time is finite, bounded, or does it just mean our perception of it is? You close your eyes and try to picture the timeline of the universe, a straight line, a circle, a spiral, a pretzel. Each option breaks something else. Linear time demands a beginning and end. Cyclic time flirts with determinism. Multiverse time forks off into infinite branches where every possibility happens. It's almost as if time doesn't care about your diagrams, And maybe that's the real answer. Maybe space and time aren't separate containers you move through. Maybe they're not even real in the way you think. Maybe they're the relationships between events, between particles, energies, choices, and asking if they have an edge is like asking if friendship has a border. It misses the point. Still, you can't help but wonder, what if time itself does have an edge? A point it can't go past? A moment where it stops being time and becomes something else? Would we notice? Would the clock stop? Would you freeze in place mid-thought, halfway through, blinking? Or would the end of time be so far away, so abstract and inaccessible that it may as well not exist at all? The truth is, you don't know, we don't know, but the fact that time even allows you to ask the question, that's something. You glance at the clock, it's later than you thought. Time, cheeky as ever, has kept moving while you sat here questioning its motives. And maybe, just maybe, that's the answer you needed. Not whether time has an edge, but that you're still in it. Right now, you blink. And just like that, a photon, one tiny particle of light, completes a journey across billions of years to land softly in your eye. You didn't feel it. You didn't notice. But it happened. Light doesn't just illuminate your surroundings. In a universe this vast, this unknowable, light is the only reason you know anything exists at all. And in this story, it's not just a messenger. It's a time traveller, a cosmic gossip, whispering across the void. Let's talk about photons, shall we? They're massless, fast-moving, relentless little creatures. Light doesn't age. It doesn't experience time the way you do. A photon born in the fiery wreckage of a dying star can travel for billions of years, uninterrupted, until it finds its way into your telescope or into your eye, telling you a story from long, long ago. And that story? It's the best we've got, because light is the only information we receive from outside Earth. It brings us images of galaxies, nebulae, supernovae, and black holes. It tells us how far away things are, how fast they're moving, even what they're made of. It's the universe's nosy neighbour, the one peeking through the blinds with a telescope and taking notes. But, and this is key, it's also limited. Not because it's shy, but because for all its speed, it can only go so fast, and space keeps pulling everything farther apart while it travels, which means there's a horizon to what light can reach. We've touched on this before, the observable universe. But let's really feel it now. Imagine standing in the centre of a giant sphere, 93 billion light years across. Every direction you look, you're seeing light that took billions of years to arrive. Not because the galaxies are old, though they are, but because the light had to cross the expanding universe to get to you, and every bit of light is from the past. Even the moon's glow is delayed by 1.3 seconds, the sun's by 8 minutes. That star you're staring at tonight? Maybe it's gone. Maybe it exploded while humans were still painting on cave walls. You just don't know yet. That's the cruel joke of light. It always shows you what was, not what is. You're surrounded by ancient whispers, by snapshots from when galaxies were young, when stars were still forming, when the universe was hot and wild and unrecognizable. Looking deeper into space is looking deeper into time. Astronomers use this to their advantage. Telescopes are time machines. Every improvement in technology lets us see a little further back, closer to the Big Bang, closer to the beginning of it all. But even the best telescope has a limit. The cosmic microwave background, CMB, that's the oldest light we can see, left over from about 380,000 years after the Big Bang. When the universe cooled just enough for atoms to form and light to travel freely. Before that, the universe was opaque, a hot, dense soup where photons couldn't go 2 inches without smashing into something. So if the universe has an edge, if it really does have some final boundary, light cannot show it to us. It's not that the edge isn't there, it's that light hasn't gotten back to tattle. Now imagine again that photon, born near the edge of the observable universe. It's been travelling toward you for nearly 14 billion years. During that time, the space between you and the source has stretched. So even though the photon's journey began from a galaxy that was, say, 3 billion light years away at the time, that galaxy is now more than 46 billion light years distant. That's the expansion of space in action. And the light? It's redshifted. Its wavelength stretched out as space itself expands. Once, it may have been ultraviolet. Now, it's infrared or even microwave. The universe stretches light like taffy until all it has left is a faint hiss of static. Ever flip to a static channel on an old TV? About 1% of that noise is cosmic background radiation, actual light from the birth of the universe, broadcast into your living room without warning. Cosmic truth hidden in late-night reruns. And here's a mind-bender for you. That redshift is one reason we can't see the real edge. Not only has the light not arrived, it may be too stretched to ever reach us. Some photons are simply lost to time, their wavelengths now longer than the size of the visible universe itself. It's like getting a postcard so faded and warped you can't tell who sent it, or where it came from. And yet we use this light to map the universe. By measuring redshifts, scientists can figure out how fast galaxies are moving away. By analysing the CMB, we can measure the density, shape and age of the universe. All from photons, just photons. Light has told us about black holes, which ironically are places where no light escapes, but we've seen their presence in how they bend light around them like a cosmic funhouse mirror. We've even photographed the shadow of a black hole, thanks to light that was bent into orbit before escaping toward Earth. Light told us the universe is expanding, that it began with a bang, that most of it is missing because the motions of galaxies suggest there's dark matter and dark energy, which don't emit or reflect light at all. They affect gravity but not light directly, which means light, for all its brilliance, is only telling you part of the story. You're trusting a gossip who only sees what glows, and you wonder what's being left out. Maybe there's an edge out there, something dramatic, a boundary where physics breaks down or where the universe curls in on itself. But light, the loyal courier, will never reach you with the message. It's like sending letters to a mailbox that's always getting farther away, and yet, even in that limitation there's poetry, because every star you see is a ghost, every galaxy a fossil. The universe doesn't send press releases, it sends photons, and you, bizarre and curious as you are, have evolved eyes that can catch them, minds that can decode them. You lie there, eyes closed now, and imagine a photon born before Earth even existed, flying through expanding space, weaving between galaxies, avoiding the grasp of black holes. Until tonight, it hits your eyelid. You'll never know which one, it'll never happen again. But in that moment, the universe said, "Hey, just so you know, I was here." Now let's step back from the photons and the time-travelling gossip and think about what it means for what you can observe, because there's a hard limit to all this cosmic storytelling, the observable universe. Everything you've seen, every galaxy, quasar or CMB ripple, is limited by the light's finite speed and the universe's age. The observable universe is like a giant sphere centered on you. That's right, you. Every observer sees their own center because no one can see farther than light has traveled to them. It's weird, really weird, like neck craning weird. You are, by definition, at the center of your own observable cosmos, which makes you feel either very special or very small. Take your pick. The radius of this observable bubble is about 46.5 billion light-years, which is already hard to imagine. But the universe itself? Likely much, much larger. Maybe infinite or maybe finite, but so vast that our observable bubble is only a tiny slice. Like seeing a single grain of sand on a beach the size of Earth, and assuming that's the whole beach. So all your questions about edges, limits or boundaries, they only apply to your observable patch. The rest is inaccessible. Maybe there's an edge out there. Maybe the universe loops on itself like a hypersphere, or maybe it stretches infinitely, uncaring and unbounded, and this is where the philosophical fun begins. Imagine the light horizon as a wall you'll never cross, not because of imagination or speed or ambition, but because the fabric of reality itself conspires against you. Even if you could travel at the speed of light, hint, you can't, the universe's expansion would keep the furthest galaxies out of reach forever. It's like chasing the horizon on a foggy day. You can run as fast as you want, but the limit recedes with every step. And because of dark energy, the recession is accelerating, so some regions of space are effectively cut off, permanently unreachable. Here's a small historical tangent. In the early 20th century, many astronomers assumed the universe was static. Einstein even added a cosmological constant to his equations to make space stop expanding. Then Hubble came along and spoiled the party by discovering galaxies are moving away. The static universe died and cosmology became a science of dynamic infinity. Fringe thinkers have proposed the concept of multiverses here. If eternal inflation is real, then our universe might just be one bubble among countless others. Each bubble could have different physical laws, different constants, maybe even different dimensions. If that's true, then the edge question is irrelevant. Not because there isn't a boundary, but because our universe is embedded in a larger structure that may be forever inaccessible. Even mainstream cosmologists sometimes admit, if there's an edge to our universe, we can't observe it. And if we can't observe it, does it matter in physics, in philosophy, maybe? In terms of the universe itself, possibly not. The light horizon also reshapes how you think about time. Events beyond your horizon are causally disconnected. Their light hasn't reached you, and it never will. Those parts of the cosmos may have existed or collapsed, or never existed at all, but they're irrelevant to your observable patch. Physics works with what can influence what, not with everything imaginable. You can feel your thoughts stretching, trying to cross the cosmic event horizon, only to be politely denied. And that's a good metaphor for the universe as a whole. Infinite, indifferent, expanding beyond the grasp of even the fastest messengers, which brings us back to the edge. If you want an edge, you'll find it in causal limits, not in physical walls. Your boundary isn't a wall in space, it's a sphere defined by the age of the universe, the speed of light, and the expansion of space. In that sense, you're standing on the edge right now, not a sharp boundary, but a soft, shifting horizon. A limit to knowledge, a place where observation fades into speculation. And yet, this edge isn't depressing, it's liberating, because it reminds you that the universe is vast beyond comprehension, and your place in it is simultaneously infinitesimal and central. You can't explore everything, you can't see everything, but you can experience this slice, this bubble, this precious corner of space-time that, by cosmic coincidence, contains you. It's also strangely comforting. If the universe is infinite or loops in ways your mind can't grasp, then the edges don't matter. The horizon is enough. The observable patch, the light that reaches you, the photons whispering ancient tales, that's all you need to feel connected. And if you ever need proof that your universe is alive, watch a meteor streak across the sky, notice the faint haze of the Milky Way, or measure the subtle redshift of a distant galaxy. Every photon tells a story, every ripple in the cosmic microwave background is a letter from billions of years ago. The universe communicates even if its boundaries are forever out of reach. You close your eyes and let this settle. Infinity, loops, edges, horizons, they're all mental constructs. What matters is what you can observe, what you can feel, what you can ponder before sleep carries you off. And maybe in your dreams the rest of the universe catches up. You're drifting now, half in thought and half in the soft embrace of the night. The cosmos has a way of doing that, pulling you out of your body, across billions of light years, into questions so vast that your limbs and worries seem insignificant by comparison. And yet, you're tethered here, lying in your own little bubble of existence, pondering what it all means. The cosmic horizon lingers in your mind, that soft, invisible line beyond which light cannot reach you. You've touched it before in your thoughts, like a fingertip brushing a silk curtain. But what lies beyond? Nobody knows. And that's the strange beauty of it. The universe doesn't just tease us, it respects the boundary of perception. Beyond it is a realm where observation ends, but possibility continues. And so you wander mentally, not through space, but through concepts. The idea of parallel universes has probably crossed your mind by now. Infinite multiverses, pocket realities, each with its own version of you reading this very script. You know the drill. It's fun, it's speculative, it doesn't answer the edge question, but it keeps the mind engaged in the gentle, spiraling haze that precedes sleep. Some physicists even argue that the universe is pixelated, granular at the smallest scales. Space itself might not be smooth, but made of discrete units, like a cosmic digital grid. That would mean that the edge isn't smooth either. It could be jagged, fuzzy, or effectively unreachable because it's woven into the very fabric of reality. Quantum mechanics loves to play these tricks. The universe has a sense of humor, subtle but relentless. Gravity too joins the cosmic symphony. It reaches across the expanse, shaping the large-scale structure of the cosmos. It's like an invisible prankster pulling galaxies together, sometimes slowing the expansion locally, but never stopping the overall march. That long-distance prank is another reminder that the universe doesn't behave like a static stage. It's dynamic, active, unpredictable in subtle ways. Now, shrink yourself down as if becoming a tiny ant on a hypersphere. Imagine walking along a curved four-dimensional surface. You can keep going straight, endlessly, yet eventually loop back to your starting point without ever encountering a wall. This is finite space with no edge, a perfect metaphor for the universe's mind-bending possibilities. And as you shrink further in your mind, the galaxy clusters above blur, the photons whisper, and the curvature becomes an intimate companion. Cartography becomes hopeless here. Imagine trying to draw a map of a space that folds in on itself. Any chart you make expands faster than you can sketch, stretching infinitely, looping back, refusing to be contained. This is the challenge of cosmic maps. They hint at structure but can never fully represent the grandeur and complexity of the universe. Infinity, paradoxically, becomes smaller in your mind. Topological tricks, loops, folds, hyperspheres, mean that what seems infinite could actually be finite but cleverly folded. Like a library where every book repeats and the shelves curve around themselves. The universe becomes a place of endless repetition and subtle constraint, defying the simple intuition of infinite extension. And finally, you return to the edge question. If there is an edge, what is it? A void? Another universe? A boundary in a higher dimensional space? Or is it something so subtle that it's effectively unreachable? An epistemic edge rather than a physical one? Your mind rests on the idea that perhaps the edge is not something you can reach, but something that exists as a limit to what can influence you. Light may never cross it, information may never arrive, but it is, in some sense, real. You feel the weight of all this, and it's surprisingly gentle. The vastness doesn't oppress, it soothes. You understand that the universe can be infinite, curved, looped, accelerating, and still give you space to breathe, to imagine, to exist. Every photon, every ripple in the cosmic microwave background, every galaxy silently fleeing into the distance is a lullaby for your mind. And as your thoughts start to slow, as the questions curl back onto themselves, you realize that the edge may not be a place you reach, but a space you accept, a horizon you learn to rest with. And in that acceptance, sleep finds you soft as a whisper, carried gently through the infinite loops, expansions, and quiet mysteries of the cosmos. Even as you drift, the echoes of infinity linger. The universe, it seems, is not only vast but stubbornly indifferent to your need for edges, boundaries, or tidy conclusions. And yet that's not a failure, it's a kind of elegance. The cosmos doesn't need to conform to intuition, it doesn't pause for your comprehension, it simply exists, stretching, looping, folding, and whispering in the language of physics. Let's return briefly to light, that eternal gossip of the cosmos. Photons traverse the universe in silent testimony to its history. Each one carries a story of a galaxy forming, a star exploding, or the very first atoms settling into a long-lived dance. And yet for all their revelations, there are regions they cannot reach. The far reaches of space are moving away faster than light can chase. They remain forever hidden. You are, in effect, an audience to a performance that is incomplete, and that's part of the wonder. Gravity, too, continues its subtle influence. Unlike light, it is not limited by speed in the classical sense when considering the expansion of space. It shapes clusters of galaxies, warps space-time, and subtly dictates the pathways along which matter and energy flow. In a universe so vast, gravity is both anchor and trickster, keeping some structures bound while letting others drift apart into oblivion. Even the largest formations, the cosmic web, the filaments of dark matter, are governed by its invisible hand, a reminder that forces stretch across scales that dwarf human intuition. Now, imagine shrinking once more, crawling along a 4D hypersphere as if you were an ant exploring a vast curved surface. You walk, straight and unwavering, yet eventually return to your starting point. No walls, no cliffs, just the gentle reassurance that finite space doesn't necessitate an edge. This looping journey is simultaneously humbling and comforting. The cosmos provides a playground for concepts your mind can barely accommodate, and in the background, topological possibilities unfold endlessly. A toroidal universe, a Klein bottle, a 3D dodecahedron. Each shape offers a different answer to the edge problem. Some allow light to loop, creating ghost images of galaxies across the sky. Some permit cosmic recurrence, echoing patterns in ways that defy observation. Each is consistent with the laws of physics, yet stretches your imagination like taffy. Meanwhile, the observable universe continues to define your boundaries. The light horizon isn't a wall, it's a limit imposed by causality. Events beyond it exist, but they cannot influence you. That realization transforms your conception of edges. not a physical barrier, but an epistemological one, the frontier of knowledge and perception. The universe has boundaries, just not in the way your intuition expects. Dark energy, quietly pervasive, accelerates this separation. Galaxies once accessible drift beyond reach, becoming permanent strangers. The universe grows not only vast, but isolating, a reminder that observation is always partial, knowledge always incomplete. Yet within this incompleteness lies the freedom to wonder, to imagine, to explore in thought what the cosmos will never allow in person. And through it all, you recognize a rhythm. Light whispers, gravity nudges, expansion stretches, time flows. Each is a piece of a larger puzzle, a framework within which you exist and perceive. The edge is not something to reach, but something to understand. It is a limit, a horizon that recedes the more you approach it, teaching patience and humility in equal measure. You let your mind slow, focusing on the sensation of the night air, the faint sounds around you, and the realization that even in a universe possibly infinite or unbounded, you are here. You're observing. You're part of the ongoing story of space and time. And for this moment, that presence is enough. You begin to notice the quiet choreography of forces shaping the cosmos. Gravity isn't the only player in this vast arena. Dark matter, though invisible, exerts its pull, weaving galaxies into clusters, forming the cosmic web and hinting at structures far larger than any one galaxy. It's an unseen scaffold, holding the universe together while expansion relentlessly pushes everything apart. You might think of it as a cosmic tension, an invisible hand shaping and restraining, a gentle reminder that even in an ever-stretching space, there's an order lurking beneath the chaos. Meanwhile, dark energy exerts the opposite effect. It accelerates the expansion, gradually pulling distant galaxies beyond the observable horizon. Over billions of years, some parts of the universe will disappear from view intensely. Even if the universe is infinite, this acceleration ensures that much of it remains inaccessible. You can imagine it as a subtle, invisible tide carrying galaxies away, isolating cosmic islands in an endless sea. The edge, once imagined as a wall or cliff, now becomes a moving boundary, defined not by matter but by the limits of causality. Shrink down in your mind again, to the scale of an ant on a four-dimensional hypersphere. Walking straight ahead, you loop back to your starting point, yet everything remains continuous. There's no edge to fall off, no point at which space stops. Finite yet unbounded, the universe becomes a place where geometry and perception diverge. Topology demonstrates that edges are not inevitable, that space can be contained in ways our intuition struggles to accommodate. And yet, observational cosmology keeps teasing the edges. Patterns in the cosmic microwave background, the faint afterglow of the Big Bang, reveal tiny fluctuations that hint at the structure of space itself. Scientists search for repeating patterns, the matched circles that could suggest a finite looping universe. So far, the sky remains stubbornly uncooperative. The cosmos, in its infinite or nearly infinite splendor, refuses to reveal its full shape. Meanwhile, time continues its relentless flow as the universe ages. Stars are born and die, galaxies collide and merge, and through it all, photons travel, tracing arcs across billions of light years, carrying information from epochs we can scarcely imagine. Some will never reach us, lost forever beyond the horizon. And yet, what we do receive is enough to construct a picture of an expanding and evolving dynamic cosmos. Here's a quirky thought to keep you awake, or maybe help you drift deeper. Space itself might be quantized at the smallest scales. Zoom in far enough and it could be grainy, like a cosmic digital screen. This discretization would complicate the notion of edges even further, making them not a smooth boundary but a jagged, subtle frontier woven into the fundamental fabric of reality. And if you combine all of these forces, gravity, dark matter, dark energy, inflation, topology, the grainy quantum structure, you begin to see the universe not as a static arena with edges, but as a living dynamic system, constantly reshaping the very space and time you occupy. The edge becomes a conceptual boundary, not a tangible one. It is where observation ends, where light cannot reach, where human understanding must pause and for a moment simply marvel. You let yourself sink deeper into this vision. Infinite or finite, curved or flat, looped or stretching forever, none of it requires an edge in the way you once imagined. The universe is a complex interconnected web, a continuum that supports thought, existence, and dreams. And for tonight, that knowledge, vague and vast, is enough. You start to consider motion on a cosmic scale. And it's more disorienting than a roller coaster in a funhouse. Galaxies aren't just static points, they're moving, not through empty space as if surfing, but carried along by the very fabric of the universe. And the further away they are, the faster they recede. The speed limit set by light seems almost irrelevant because space itself is stretching, expanding the distance between objects faster than light could ever traverse it. Your mind flutters at the thought, motion not as displacement in space, but as expansion of space itself. This makes you rethink what it even means to travel through the universe. You can fly a spaceship at top speed, dodge asteroids and navigate solar systems, but galaxies beyond your local cluster will remain unreachable, forever slipping past, no matter your velocity. Light from some distant points will never reach you because the expansion is too fast. You're observing an ever-growing horizon, a shifting edge that recedes with cosmic patience. Now imagine shrinking down again, walking as an ant across a curved surface, a hypersphere. You take each step in a straight line, and eventually, without ever turning, you arrive back at your starting point. No cliffs, no walls, a finite path yet unbounded. It's a mind-bending visualization of how the universe could be finite but edgeless. Topology allows these possibilities, showing that space can fold, loop, and reconnect in ways that evade simple intuition. Consider, too, how maps fail. Astronomers attempt to chart this vastness, but the further out they go, the more stretching and warping occurs. Any attempt to flatten it onto paper distorts distances and angles. Cosmic cartography becomes impossible in a literal sense. The map keeps expanding as fast as the terrain does. The universe resists being contained, reminding you that edges are a human concept, not a cosmic necessity. And gravity still plays its part, gently weaving the structure of the cosmos. Galaxy clusters hold together against expansion, filaments of dark matter shape the cosmic web, and the pull of unseen forces maintains a delicate balance. Meanwhile, dark energy accelerates the expansion elsewhere, ensuring that some regions drift beyond contact forever. The edge isn't a cliff, it's a shifting horizon defined by observation and causality. Think about quantum granularity. Space may be discrete at the tiniest scales, giving the edges a fuzzy digital texture. No hard walls, just a lattice of reality, where what appears continuous is actually stitched from tiny pieces. Combine this with inflation, acceleration, topology, and the limitations of light, and the universe starts to feel less like a box and more like a dynamic, living system, infinite in potential yet finite in the way you can perceive it. You settle into that thought. Infinity, curvature, expansion, and limits are not threats. They're a lullaby. Each galaxy drifting, each photon travelling from the dawn of time is a note in a cosmic symphony. And you, small but conscious, are part of it. The edge isn't something to reach, it's a horizon to rest beside. And in that space, sleep begins to find you. As your mind drifts further, you begin to think about the universe from the perspective of an ant, or a miniature observer on a 4D hypersphere. It's a strange, almost silly mental exercise, but it's illuminating. You walk straight ahead, taking careful, infinite steps, only to find that after a very long journey, you end up back where you started. No walls, no edges, no cliffs, just continuous looping space. Finite in volume, yes, but unbounded in a way that defies everyday intuition. It's like a cosmic Mobius strip, a place where the concept of an edge becomes meaningless. This is the essence of topology and cosmology. The universe could be shaped in ways that allow finite space without the need for boundaries. A torus, a dodecahedron, or even a Klein bottle all offer pathways for space to curve back on itself, letting you travel forever without ever encountering an edge. And the most astonishing part, it would still feel locally flat. You could walk for millions of light years and never notice the curvature. Only on cosmic scales would the geometry reveal itself. Astronomers have attempted to detect such shapes by looking for repeating patterns in the cosmic microwave background, searching for matched circles that might hint light has wrapped around the universe. So far, the results are inconclusive. Perhaps the loops are too large for our instruments, or the universe is infinite. Maybe it's both, in ways that your mind cannot fully grasp. And historians still argue about the limits of observational cosmology. How much can we truly know if the universe is fundamentally unobservable at its largest scales? Meanwhile, expansion continues. Galaxies drift apart, carried not by motion through space, but by the stretching of space itself. Distant galaxies recede faster than light due to the expansion of, and over billions of years, they'll slip beyond our cosmic horizon, permanently unreachable. That horizon, not a wall but a limit defined by the speed of light and causality, is the closest thing to an edge you can conceptually encounter. It's less of a barrier and more of a soft, receding boundary, always moving outward as the universe ages. Quantum theory adds another layer of complexity. Some models suggest that space itself is quantized, granular at the smallest scales. At these levels, the universe's edges might not be smooth, but jagged, composed of discrete units of space-time. The fabric itself is woven from something indivisible, making the concept of a continuous boundary meaningless. Any edge, if it exists, would be lost in the grain of reality. And then there's dark matter and dark energy, the silent architects of cosmic structure and expansion. Dark matter anchors galaxies and clusters, creating the scaffolding that shapes the large-scale cosmos. Dark energy, by contrast, accelerates expansion, stretching regions of the universe beyond our reach. These opposing forces define the universe's rhythm, a dynamic interplay that makes edges redundant. There's structure without borders, motion without walls, limits defined by observation rather than matter. All of this leads you to a subtle realization. The universe's edge isn't physical, it's conceptual. It's a horizon of knowledge and influence, a boundary determined by light, expansion, and the geometry of space-time. You can't reach it, but you can understand its existence, and in understanding it, you find a strange calm. The universe doesn't need edges to be complete. It simply exists, expansive, looping and intricate, and you are a part of its quiet unfolding. You've been lying under the stars for a while now, letting the vastness of the cosmos seep into your thoughts. Infinity is no longer an abstract concept, it's a mental landscape you're wandering through. But here's a twist that will keep your brain gently buzzing while your body drifts towards sleep. Infinity might actually be smaller than it seems. It's counterintuitive, really counterintuitive. But it comes from the strange, quirky rules of topology. The universe could be finite, looped, and cleverly folded in ways that make distances feel infinite, even when the total volume is not. Picture a 3D video game world where walking in one direction eventually brings you back to where you started. The universe could be that, only incomprehensibly larger. With cosmic rays and photons looping endlessly through the folds, carrying messages across billions of years. This is where mathematics becomes your secret telescope. Even if the universe is finite, the topology might allow multiple paths for light. A single galaxy could, theoretically, be observed from different directions as its light wraps around the universe. Ghostly echoes of the same structures could appear in multiple places, like a cosmic funhouse mirror. So an edge isn't necessary, and infinity becomes a matter of perception rather than an absolute. At the same time, the observable universe constrains your experience. Light travels at a finite speed, and the universe has a finite age. This sets a horizon, a boundary beyond which photons haven't had time to reach you. The horizon isn't a physical edge, it's the limit of information. And dark energy, subtly accelerating the expansion of space, ensures that some regions will never cross that limit. It's as if the universe is gently, insistently reminding you that you can know only so much. Think of it this way. If the universe loops like a hypersphere, then the edge you imagine is merely a horizon of perception. Beyond it, the cosmos may repeat, fold back, or even branch into unseen possibilities. The universe might contain structures that are mirrored, rotated, or completely alien to your senses, but they remain inaccessible. And even if an actual boundary exists in some higher dimensional space, you would never experience it. Dark matter adds another layer to this cosmic dance. Invisible yet pervasive, it sculpts the large-scale structure of galaxies and clusters. Gravity, meanwhile, keeps these systems bound, even as the space between them stretches. These forces shape the universe without defining edges, creating form, motion, and a kind of order within the apparent chaos. Now let your mind wander to cosmic maps. the cartographer's attempts to chart a domain larger than imagination. Any map of the universe distorts distances, curvatures, and angles because space itself stretches and bends. Trying to chart infinity is a fool's task, but it's also beautiful. You see hints of structure, threads of the cosmic web, shadows of unseen matter. The universe reveals itself in patterns, ripples, and subtle motions, not in walls or borders. And this is the subtle truth of edges. They don't exist as physical barriers. Instead, they are epistemic boundaries, limits of observation, perception, and causality. You will never fall off the edge because there is no edge to fall from. You will never reach the end because the universe is either infinite, curved, looped, or expanding faster than you can traverse. As you lie there, enveloped in this realization, infinity becomes less terrifying. It's a playground for thought, a canvas of potential, a gently expanding stage for your consciousness. The universe stretches and loops, carries photons, folds space, bends time, and yet still finds a way to cradle you within its patterns, letting you ponder, imagine, and drift into sleep. The horizon has settled in your mind now. You can picture it. A soft, receding boundary defined not by walls or cliffs, but by the interplay of light, expansion, and causality. And here's the intriguing question. If there is an edge, what's beyond it? Your intuition probably wants a void, a vacuum, or a blank sheet of nothingness. But physics is rarely that simple. One possibility is that beyond our observable patch lies more universe, stretching infinitely, repeating, looping, or forming patterns we cannot detect. Perhaps the cosmos continues in a way that mirrors our local structures, or perhaps it's utterly alien, obeying the same laws but presenting forms, arrangements, and events beyond imagination. And if this is the case, the edge of your observation is not a boundary of reality, it's a window of perception, the limit of what can influence you. Some cosmologists have explored more exotic ideas. Eternal inflation suggests our universe is a bubble within a vast multiverse. Each bubble could have its own constants, particles, and dimensional rules. In this view, an edge might exist, but it wouldn't mark the end of all reality, merely the end of this bubble. The beyond is not nothing. It's another set of possibilities, another domain of physics, inaccessible to us. And even if the universe were finite, topology allows it to loop. A finite universe can be unbounded, like a hypersphere or a three-torus. Walk in one direction long enough and you return to your starting point. You never encounter a wall or a drop, just continuous looping space. In such a scenario, the edge exists only as a concept, a limit to the human imagination, not as a physical structure. Then there's the subtlety of light and observation. The farthest galaxies you see are not where they appear. They have moved since their photons began their journey. Expansion stretches light, redshifts it, and can push it beyond detectability. Regions may be forever hidden, their photons never reaching you. Even if there's structure, even if there's an edge, it's outside your causal horizon. The universe's edge, if it exists, remains epistemic rather than physical. Quantum considerations add another layer. Space might be discrete, pixelated at the smallest scales. If so, an edge wouldn't be smooth, it would be jagged, woven into the fundamental fabric of reality. And if the universe is embedded in higher dimensions, an edge could exist in ways that our three-dimensional perception cannot comprehend. It might be there, but invisible and unreachable, like a secret room behind a wall that doesn't exist in your current dimensions. What if ultimately the edge isn't about space at all? Maybe it's a boundary in knowledge, a limit to what can influence you. Light, gravity, and information are all finite, and that sets the edges of experience. Beyond them, the universe continues, but you will never know it. It's a comforting, paradoxical notion. Vastness without danger, infinity without panic, edges without walls. And now, lying in the quiet, you realize the edge, whether it exists or not, is irrelevant. The universe doesn't need edges to be beautiful. The infinite loops, the expanding fabric, the photons, the dark energy, the curvature and topology, all of it exists. You exist. Observation, curiosity, and consciousness fold into the cosmos, giving you a kind of quiet centrality, even in an unbounded, edgeless universe. The stars above remain constant, the Milky Way stretching softly across the sky, and in their presence the question of the edge becomes a lullaby, vast, ungraspable, endlessly mysterious, yet deeply intimately yours. You lean back once more, letting the weight of the universe settle around you, the edges of thought dissolving into the folds of space-time. All the ideas you've explored, the infinite stretches, the looping topologies, the limits of observation, the acceleration of distant galaxies merge into a gentle rhythm. You are a participant in a cosmic symphony, attuned to vibrations older than any human memory. If there is an edge, it is unreachable. If the universe is infinite, it is unbounded. If space loops, you will never know it from a single vantage point. All of these possibilities coexist, layered like notes, in a slow, meditative chord. Each photon that brushes past your retina, each whisper of gravity from distant clusters, is a reminder that you are part of something vast, complex and dynamic. And yet none of this diminishes the profound intimacy of your experience. For all the distances, expansions, and unseen regions, you exist in the universe here and now. You occupy a unique point in the cosmic web, surrounded by the echoes of billions of years of light, energy, and matter. Your perception is limited, but within that bubble, the universe is yours to explore in thought. Consider the edges one last time. They are conceptual, defined by light, causality, and human understanding rather than solid walls. They recede with the expansion of space, stretch beyond reach, or loop back into the continuum. You cannot fall off because there is no cliff. You cannot cross over because the horizon is set by what information can reach you. And even if the universe hides boundaries in higher dimensions or quantum granularity, they are imperceptible, intangible, and irrelevant to your experience. In the quiet, you realize the profound lesson. The edge doesn't matter. Infinity, curvature, and the limitations of observation don't confine you. They frame a universe that is endlessly generous in its mysteries. The cosmic dance continues, unobserved yet perfect in its unfolding, and your consciousness is a small luminous thread woven into that pattern. Sleep begins to hover at the edges of your awareness, soft as a whisper. You feel your heartbeat sync rhythmically with the slow, patient motions of distant galaxies. The stars above shine steadily, a reminder of the constancy underlying the vast, shifting expanse. And in that quiet communion, you sense the universe curling gently around itself, looping, stretching, infinite, yet intimate. Your thoughts drift into that horizon, the soft boundary of perception, and finally you let go, letting sleep carry you along the gentle currents of space-time, where questions of edges, infinity, and the farthest reaches of reality dissolve into dreams. The universe continues, you continue. And everything is exactly as it should be. The night lingers as your mind floats between consciousness and the gentle pull of sleep. The cosmos, vast and unyielding, continues its endless dance. Galaxies drifting, photons racing, space stretching, time flowing. You feel the enormity of it, but it does not overwhelm. It comforts. Even infinity, loops and unseen regions become a lullaby, a steady rhythm you can rest within. Edges, if they exist, are not cliffs, but horizons of understanding. Light can't reach beyond them, gravity can't pull past them, and your senses will never touch them. They are boundaries defined not by matter, but by the limits of knowledge itself, and that is enough. You are here, alive, conscious, breathing in a small bubble of reality into which stars shine, galaxies whirl, and photons whisper tales from billions of years ago. You imagine walking on a hypersphere, looping without encountering walls. Space curves gently, finite yet unbounded. Dark matter, dark energy, and the invisible structures of the universe provide rhythm and order, yet nothing constrains your imagination. Time flows around you, steady, infinite, or cyclic, carrying your thoughts along its gentle current. You are both observer and participant, a small but vital thread in a vast cosmic tapestry. The stars above, the faint hum of air, the soft contours of night, all combine into a comforting chorus. You feel connected, present, and safe in a universe that is endlessly large, intricately structured, yet intimate in its invitation to wonder. And as your body relaxes and your thoughts slow, the horizon fades, infinity softens, and sleep arrives quietly, folding you into the gentle embrace of the cosmos itself.